Hello everyone and welcome back. In this new section of the course we are going to do a quick consolidation exercise before introducing new concepts. So we are going to be writing in reactive style another screen of our application, which is going to be the course screen. This is the screen that gets displayed whenever we click here in one of the View Course buttons on our course card list. For example, when we click here on View Course, we are going to be redirected to a new screen that is going to show here the title of the course, a description, and also a list of lessons. The course page component corresponds to the course component that we see here on the screen that you can find inside the course folder. Now let's have a quick look at the initial version of the component that we already have here. We can see that we have defined here a couple of member variables, but these for the moment are plain variables as opposed to observables. Let's also have a look here at the template. We can see that we have here a container div with the class course. We can see here the course description, the course thumbnail, and we can see here a list of lessons. So we are iterating here through the lessons member variable using the ng4 core directive. Let's then start the implementation of our course component in reactive style. So the first thing that we need to do in order to implement this in reactive style is to use observable member variables as opposed to plain member variables. So let's make this an observable of course, and let's also make this member variable an observable of lesson array. Now the first thing that we need to do when we initialize the course component is to fetch the course data from the backend. In order to do that, we are going to need the course unique identifier. If we have a look at how the course component is being used using Alt Command F7, we're going to see that we have here some routing configuration for this component in our application routing module. We can see that we are going to reach this component whenever we hit the path /courses/course ID. So this means that from the URL, we are going to be able to extract the course identifier. Going back here to our component, let's see how we're going to do that using here the activated route. We are going to access the activated route. We are going to access the current snapshot of the route, and we're going to access the URL parameter map. From here, we are going to get the parameter course ID. With this, we now have here the course identifier that we're going to assign here to a local variable. Now, what we're getting here from the parameter map is always going to be a string. So let's go ahead and apply here parseInt in order to convert this into an integer. Now we need to take the course identifier and we need to call our backend and fetch the course data. So for that, we're going to be using the courses service that we're going to be injecting here in our constructor. The courses service is going to contain a new method in its public API that is going to be called loadCourseById. This method is going to take a single input parameter, which is going to be the course identifier, which will be of type number. We are then going to hit our backend endpoint using an HTTP GET call, and we are going to access the endpoint /API/courses, and then here we need to add the course identifier of the course that we want to fetch from the backend. As usual, we are going to apply here the pipe syntax, and we are going to use here share replay in order to avoid that multiple subscriptions to this observable accidentally trigger the same HTTP call. Now that we have here load course ID implemented, we can go back here to our course component and we can populate the course member variable. We're going to access here courses service, we're going to call loadCourseById, and we're going to pass in the course identifier. Notice that we get here at this moment a compilation error, and this is because here in loadCourseById we accidentally did not return here this HTTP observable. So now that we have returned here an observable, let's add here the parametric type of the value returned. So this is going to be a course that we get back from the backend, and with this we have now fixed our compilation error. Now that we have our course data available via the course observable, let's go ahead and consume the data in our template. So as we can see, our course variable here is not yet available. let's go ahead and add here an ng container tag, and using the Angular ngIf directive, we are going to make this data available to the template in the following way. We are going to subscribe here to the course observable using, as usual, the Angular async pipe, and let's give the values emitted by this observable an alternative template name. We are going to call this the course template variable. Now we are going to take here our course container and we're going to move it inside our ng container tag. And this way our course variable is already available here, and we can now display the course thumbnail and the course description. What we can't display yet are the course lessons. Let's then go ahead and for the moment comment out this part of our HTML table. We are going to later on fetch also the lessons from our backend. Let's now try out this new version of our course component. We have already refreshed here our application. Let's then go ahead and click here on View Course, and as we do so, we can see that we are correctly displaying here the title of the course and the thumbnail. The lessons table is still empty for the moment. Let's click here in another course from our list, for example here the RxJs in practice course, and as we can see the correct thumbnail and title are being displayed as expected. So we have now implemented the first part of our course page. Let's go ahead and implement the lessons table as well. While we implement the lessons table, we are going to come across a common problem while developing applications in reactive style, and we're going to introduce a new design pattern to solve it, the single data observable pattern. This is coming right up in the next few lessons. Hello everyone and welcome back. In this lesson we're going to continue the implementation of our course component. So we have already sent to the template the course data using the course observable. Let's now do the same with the lessons data. We are going to be fetching the lessons data from the backend in a separate HTTP request. Let's then go ahead to our courses service and let's add here a new method in its public API called load all course lessons. This method is going to take only one input parameter, which is going to be the course identifier for which we want to fetch all the lessons. Let's already define here the return type for this method, so this is going to be an observable of lesson array. Let's now define the implementation of load all course lessons, and this is going to be very similar to the implementation of search lessons, meaning that we will also be hitting here the /API/lessons backend REST endpoint, but this time around we are not going to be passing a search criteria. Instead, we're going to be passing a course identifier. So let's go ahead and take this code here and let's paste it inside the body of load all course lessons. So we are not going to be filling in a search criteria. We are going to increase page size to a very large number so that we are sure that we get back all the lessons from the course, which might be at maximum a few hundred records typically. And we are now going to pass in here another parameter, which is going to be the course identifier. We're going to pass in here the course ID variable, and this needs to be a string. So let's go ahead and call toString on our course identifier. And with this, we have finished the implementation of load all course lessons. Let's go ahead and switch to our course component and use this new method in order to fill in the lessons observable. Let's access here the courses service and let's call load all course lessons, passing in the course identifier. So now we have here a new lessons observable. Let's go ahead and consume it in our template. So how are we going to do this? In a very similar way to what we did here to the course observable, we are going to add here another ng container tag. We are going to be applying the same syntax that we did for the course observable. We are going to apply ngIf, we're going to access the lessons observable, apply it the async pipe, and then we're going to define here an alias for the values emitted, which are going to be the lessons of a given course. Now we can go ahead and take this container div containing all the HTML of our course, and we're going to move it inside this nested ng container tag. We can now use the lessons variable to iterate through all the lessons and display them in our lessons list. Now, notice what we did here. We had to nest several ng container tags in order to consume all the observables from our component. In our next lesson, we're going to see a better way of doing this because, as you can imagine, in a more complex component that has 5, 6, 7 observables, we would get here 7 nested ng container tags, which looks really ugly and it's not very practical or maintainable. Before discussing how we're going to avoid having here nested ng container tags, let's go ahead and test the current version of our courses component. So I have already reloaded here the new version of the component. Let's then go ahead and click here on View Course. So this is the new version of our component. As we can see, we have here the course title, the course thumbnail, and we now have here a list of lessons as expected. Now, you might have noticed whenever we reload the screen that the screen remains blank initially and then it displays all the data in one go. So this is because of the way that we implemented our screen. We are only going to be displaying this HTML block, which corresponds to the whole page, when we have both the course and the lessons as well. In our next lesson, we're going to learn a new design pattern that is going to avoid having to use nested ng containers, and that is also going to help with this initial delay in displaying data to the user while the screen starts up. Hello everyone and welcome back. In this new lesson, we're going to introduce a new reactive Angular design pattern, the single data observable pattern. The goal of this pattern is, among other things, to avoid the use of nested ng container tags like we have here in this simple component. So in this component, we have here two observables defined, the course observable and the lessons observable. We can see that these correspond to two separate HTTP requests that are being made to our backend using the courses service. These two data observables are then fed to the Angular template using the typical ng-if syntax that goes like this. We take the observable, we apply the async pipe, and we give to the values emitted by the observable a template variable that we can then use inside our template to display the data. In this case, because our template consumes two separate observables, we are using here two nested ng container tags. You can imagine in a more complex component that needs to consume 5, 6 or even more observables, that we would have to have here 5 or 7 nested ng container tags, which is not very convenient and it's also not very maintainable. Besides the maintainability aspect, there is also another problem. Take a look, whenever we load here our component, we can see that there is this blank moment where no data gets displayed, and then only when both the course observable and the lessons observable emit values, only in that case are we going to display some HTML to the user. Now imagine that it takes a lot longer to fetch lessons from the backend than to fetch the course data. We would like that the user could see at least the title and the thumbnail of the course while the lessons get loaded. So we would like to have the template display the data as soon as it's available and not necessarily only when all the observables have emitted a value. However, the use of nested ng container tags avoids that. We cannot display any HTML to the user as long as the lessons observable does not emit its first value. Now, we could refactor our component to avoid that, moving the part of the template that needs the course observable here between these two ng container tags, but this is also not very convenient either. And this is because in many cases our template cannot be conveniently separated into different sections that use only one of our observables. Many times our data is used in many different places throughout the page. Let's now present a way to avoid having to use these nested ng container tags and also allow the template to receive the data as soon as it's available. What we're going to do is very simple to solve this. Instead of feeding our template with multiple observables and therefore multiple ng container tags that we have to nest inside each other, let's instead feed our template with a single observable containing all the data that the template needs. And we are going to call this the single data observable pattern. Let's see what this looks like. We're going to switch here to our component and we're going to start to define here above the component a new data interface, and we're going to call this course data. So here we are going to be defining all the data that the course component needs. We are defining this directly inside the course component file, and we are not exporting this because this course data interface is only going to be used inside our course component file. So here we are going to be defining all the data that our page needs, and this will include the course, and it will also include the course lessons. Let's then go ahead and define here a lesson array. So now that we have defined the data that our page needs, instead of defining here multiple different observables, we are going to delete them all, and we are going to define here a single observable that we're going to call data. This new observable is going to emit values of type course data. Before showing how we are going to define this new data observable, let's go ahead and see first how it's going to be consumed by our template. So instead of having here multiple nested ng container tags, we are going to have here only one ng container tag. Now here the difference is not very noticeable, but imagine that you would have here 6 or 7 nested ng container tags. Now you have only one. We're going to access here the data observable, and we're going to alias the values emitted. We're going to create here a variable called data. Now we can use data to access the course wherever we need it. So we access here the course a first time, and now let's access here the course a second time to fetch the course icon URL. We can also access here the course lessons in a very similar way. As we can see, this design pattern makes it very simple to write our templates in a much more maintainable way without the need of using ng container tags everywhere just to access observable data. Let's now switch back to our component and see how we're going to define this data observable. Our strategy is going to be simple. We're going to define this data observable by combining multiple other observables. So the first observable that we're going to use is going to be the course observable that we're going to define here as a local variable, and let's also define here the lessons observable also as a local variable. Now, how are we going to define this derived data observable based on these two observables, course and lessons? Well, we would like the data observable to emit new values anytime that either course or lessons emits a value. So we are not going to wait for both observables to emit a value. Instead, we want to emit a first value containing only the course, and then when the lessons data is available, we will be emitting a second value containing both the course and the lessons. This way, we are going to be able to feed the template with data as soon as the data is available from the backend. So in order to create our derived data observable, we are going to be using the RxJs combine latest factory function. This takes as input an array containing the multiple observables that we want to combine. So in our case, we want to combine the course observable with the lessons observable. And notice that the returned value by combine latest is going to be an observable whose values emitted are tuples. So they are not objects containing these particular properties here. Instead, combine latest is going to be emitting TypeScript tuples, which at runtime are arrays, where in this case the position 0 of the array would contain the values emitted by the course observable, and position 1 would contain the values emitted by the lessons observable. This is not, however, the format that we want for our data observable, so let's go ahead and apply here the RxJS pipe syntax. and we're going to apply here the RxJs map operator. Here we are going to take the values emitted by the combined latest observable, which are going to be tuples of values, and we're going to be returning here as the output of our map operator a value of type course data. So the values that we receive here on map are tuples of courses and lessons. So let's go ahead and define here the first value, which is going to be a course, and the second value, which is going to contain a lessons array. And using this, we are going to return here an object of type course data. So first we're going to fill in the course property, and then we're going to fill in the lessons property. And with this, we have fixed all the compilation errors, and we have now defined the derived data observable. As we can see, this data observable is produced by combining two different observables using combined latest. Whenever one of these observables emits a value, we're going to be emitting here a new value of type course data, and we are going to be feeding the template with the data that we received from the backend as soon as we get it. Now, before trying out the new implementation of our course component, let's also add here some logging to our combined observable. We're going to apply here the tap operator, and we're going to log to the console all the values emitted by this observable so that we understand better how it works. Let's now try everything out. We are going to switch here to a larger window, and we're going to access the course page. Take a close look here at the screen while we transition from the courses page to the course page. We can see here that the data is still being correctly displayed as expected, and we can see here the values emitted by the data observable. So as we can see, we have only emitted one value for this observable. This value contains two properties. One is the course property, containing the course object with the description, thumbnail, etc. And we also have here a lessons property, which is an array of lessons. Now, unlike what we would expect, we can see that the data was displayed to the user all at the same time. And this is because only one value is being emitted by our combined data observable. So if we refresh here, we can see that we have here a completely blank screen, and all of a sudden we have both the courses and the lessons. This corresponds to the fact that only one value was emitted by our data observable. So in our next lesson, we're going to see how can we display the course data once it's available while we wait for the lessons to arrive from the backend. Hello everyone, and welcome back. As we have seen in our last lesson, this single data observable pattern that we have used on the course component is a very convenient way for avoiding having to nest ng container tags in our template in the case that our template needs data coming from several different observable sources. However, when we switch here to a larger window, we can see that our implementation is not yet fully working as we want it to. So if we refresh here the page, we can see that we get here an initial blank screen, and only when the data observable emits its first value do we then display the data to the user. So this is not the behavior that we would want. The course data is available much sooner than the lessons data in our application. So we would like to be able to display to the user the course title and the thumbnail while the lessons are still loading. This means that we would like our data observable to emit two values. One initial value containing only the course once it's available, and a second value containing both the course and the lessons once the lessons are available from the backend. Let's see how can we achieve that. Going back here to the definition of our data observable, we can see that we are using here the combined latest factory function. So combined latest is going to make sure that a new value gets emitted whenever one of the observables emits a value. So we could be led to believe that that's exactly the behavior that we want, but there is a minor problem with this, which is the combined latest observable has a slightly different logic for the first value emitted. So for the first value emitted by the combined observable, combined latest is going to wait for both the course and the lessons to emit its first value. Only then will combined latest emit its first value as well. After that, whenever course or lessons emit new values, then combine latest is going to emit a new value containing all the latest values for each observable. But this will only happen after the first value was emitted. For the first value, combine latest is going to wait for all the observables to emit its first value. So how can we then modify the definition of our data observable in order to make sure that we emit here the course data as soon as it's available? We need to have the course and the lessons observable both emit an initial value, and we can achieve that by using the RxJs pipe syntax and by applying here the RxJs start with operator. This is going to make sure that our course observable is initialized, for example, with a null value. So the course observable is going to first emit null, and then it's going to emit the course that we got from the backend. We need to apply a very similar logic here to the lessons observable. So we're going to apply the pipe syntax and we're going to have it emit as initial value the empty array. Let's now try out our new implementation to make sure that everything is working as expected. Let's keep an eye here on this part of the template that depends on the availability of the course data emitted by the course observable. We are going to do a refresh and notice that here we managed to see both the title and the thumbnail of the course while the lessons data was still loading. Let's try that once again. We can see here the title of the course and the thumbnail. Now we could also see here that there was, for a very brief moment, an empty HTML table, and that looked a little bit strange to the user. So let's go ahead and switch here to our component template and improve things a bit. We are going to make sure that the lessons table remains hidden while there is no lessons data yet available. We're going to be using here ngIf, and we're going to access data.lessons. And we're going to make sure that the length of the array is larger than 0. Let's try this out. We are going to refresh here the application. And this time around, we can see the course data, and after that, we see the lessons data without any intermediate version of the data table being displayed to the user. So this is a much more natural user experience. Let's try this out again. You can see here the course data, and after a moment, the lessons data also arrives from the backend. Let's now confirm in a larger window the new behavior of the data observable. So as you can see, whenever we reload here our course screen, we're going to have an initial value containing a null course and an empty lessons array. This is our initial value caused by the use of the start with operator in each of the combined observables. And then when the course arrives from the backend, we have a new value containing the course object, but still having here an empty lessons array. And after a moment, when the lessons are available from the backend, we have a new value emitted containing both the course and the lessons. We could also see here that there was a slight problem here with the course image. We see here an empty image being displayed by a brief moment while the data gets loaded from the backend. So let's go ahead and further improve our template. We're going to switch here to our HTML template, and we're going to add here an ngIf condition also to the image thumbnail. We're going to display this only if the course is available. Let's try this out here on a larger window. We're going to refresh the application using the Angular CLI, and as we can see, we no longer have that broken image displayed to the user. We have the title of the course, then the image loads from our server, and after that, when the lessons are available, then the lessons table gets displayed as expected. Let's now go back to our program and talk a little bit about the single data observable pattern that we have implemented here. So as you can see, the idea is to create a single data observable that we are going to be passing to our template using a single ng container tag. we can make so that the data is available to the multiple parts of the page as it becomes available from the backend, and we don't necessarily have to wait for all the data to be available before starting to display parts of the page to the user if that's the behavior that we are looking for. Now, in the particular case of our course component, because it's a very simple component, the benefits of this pattern might not be immediately apparent. But imagine a much larger component that is getting fed observable data sources coming from many different places of the application, for example, a Redux-style centralized store, backend requests, etc. And we want to combine all those observable data sources and feed that data to the template. Then in that case, in the case of a much more complex screen, then the single data observable pattern is a lifesaver. It's important to understand while applying the single data observable pattern that you don't have to necessarily use the combine latest operator. In most cases, this is going to give you the behavior that you are looking for, which is the ability of feeding the template with the data as soon as it's available. And with this, we finished our explanation of the single data observable pattern, and we are now almost at the end of the course. We are now going to see, before the conclusions lesson, how easy it is to adapt our application to use on-push change detection. Hello everyone, and welcome back. In this new lesson, we're going to learn about one of the many benefits of writing our application in reactive style. We're going to see how simple it is to convert our application in order to use the on-push Angular change detection mode as opposed to the default change detection mode that our application is currently using. So what is on-push change detection? This is an optimized, faster change detection mode that Angular has available to us, but that it's not on by default. So by default, Angular is going to check all the template expressions, such as, for example, here the courses property, or any other expression in any of the templates of our application in order to determine if a given component should be re-rendered or not. As we can imagine, the default change detection mode might not be sufficient for large applications with a lot of Angular template expressions. It's important to understand that for most cases, default change detection is going to work great for the majority of use cases. It's only when you have a lot of data to show to the user with a lot of template expressions that it might become a problem. In those rare cases where the amount of data that we are trying to display makes the UI less responsive, we might want to switch some of the components of our application to use Angular on-push change detection. With on-push change detection, Angular is only going to update the component if we push new data to it explicitly. So Angular is not going to check all the expressions by default. Instead, Angular is going to wait for data to be explicitly pushed to the component before re-rendering it. There are a couple of ways of pushing data to a component. One way is through the use of Angular input properties, such as, for example, here the courses input of the course card list component. In on-push change detection, Angular is going to detect if some of the input properties of certain components change or not, and based on detecting or not a change, Angular is going to decide if the component needs to be re-rendered. Another way that Angular has to detect if some data is being pushed to a component is by checking if any of the observables that the Angular template has subscribed to has emitted a new value. So those are the two ways that Angular has available in order to detect if some new data is being pushed to the component. As you can imagine, re-rendering only the components that we know that have received new data is more efficient than checking every single component each time. So, for large applications with a large amount of data, we would expect that on-push change detection is faster than the default change detection and that it gives us a more responsive application. So, if we would like to convert our sample application to on-push change detection, here is what we need to do. we need to identify the components that are going to be using on push. Let's start, for example, with the home component that we see here on the screen that is consuming here a couple of observables on its template using the async pipe. We can switch this component to on-push change detection by using the change detection property of the component decorator. We're going to set this to on-push instead of the default change detection strategy. And we're going to do the same for other components in our application that we believe that would benefit from on-push change detection. Here, as a demonstration, we're going to apply this to multiple different types of components. So here we have applied it to a smart component, which is the home component, that is aware of the service layer and it pushes data to the template using observables, but we can also apply it here to a purely presentational component such as the courses card list component that receives the data via Angular inputs only. So just like the home component, we can also set this to on-push change detection. We can go ahead and also apply the same change detection strategy to the search lessons component and also to the course page, which is implemented by the course component. And with this, we have modified several of the components of our application in order to use on-push change detection. Let's now switch to a larger window and do a final test of our application. We are going to start by testing the home component. Let's go ahead and refresh here the application, and as we can see, the home component is still working as expected. Whenever the courses data is received from the backend, we can see that it ends up being correctly applied here to our home component template and to the course card list component as well. Let's now do here a data modification. We're going to use the edit course dialog. Let's change here the title of the course. Let's switch the category from beginner to advanced. We're going to click save, and as we can see, the data was again immediately applied to the template, even though the components are working in on-push change detection. Let's try this again. I'm going to change again the title of the course. Let's switch it to beginner, and as we can see, everything is working as expected. The UI is still being immediately updated while working in on-push change detection. Let's now try out other components of our application. We're going to click here on View Course, and we're going to see that our component is still working as expected. If we try out other courses on our course list, we're going to see that everything is still working correctly. Let's now try out the search lessons component. We are going to type here, for example, the search intro. We're going to click here on search, and as we can see, the data is still getting applied to the template. So we have multiple components of the application working in on-push change detection mode, just as well as with normal change detection. We managed to do so because we have decided to write our application in reactive style. In reactive style, all the data that gets passed to our templates is coming either from observable member variables that are subscribed to by the async pipe in our templates or via Angular input variables. This means that whenever the data of one of these observables changes, the Angular framework gets notified that new data is available via the async pipe, and that's what allows the Angular on-push change detection mode to work so well with this type of applications. As we can see, the ability to easily use on-push change detection is one of the many reasons that we have for wanting to write our applications in reactive style. And with this, we have reached the end of the course. Let's now talk about some key conclusions and takeaways in our next lesson. Hello everyone, welcome and congratulations on completing this course. We still have the final conclusion lesson with some key takeaways on this course. But before that, this is the bonus lecture of this course. We're going to talk about some of the other courses that you have available here on the Angular University if you want to take the next step and dive deeper into the Angular ecosystem. In the next lesson, you are going to receive coupons to all the courses, and we are also going to give you the course conclusion with the key takeaways. Right now, let's have a quick look at all the courses that you have available in the Angular University. One of our most popular courses is our RxJs in Practice course. Another very popular course is the NGRX course, and we have other courses for many other subtopics. If you want to learn about Angular server-side rendering, we have here the Angular Universal Masterclass. If you want to learn about Angular Material, we have here the Angular Material course for that. We have a course on progressive web applications, on Angular security, forms, the router. We have an advanced masterclass where we are going to be building a series of open source libraries and deploying it on npm. And we have here a complete reactive pattern catalog for building applications in Angular, but we're going to design our application in plain RxJS as opposed to using here a store library. And we have several other courses. We have new courses getting released all the time. In the next lecture, which is going to be a text lecture, you will have available coupons for all these courses. You will have the courses available at the best possible price. These coupons will not expire, so you can always come back here and get another course using the links provided in the next lecture. So I want to thank you for watching. I hope that you have enjoyed this course. Any issues or questions, please let me know in the comment section or send me a private Udemy message and I will get back to you. Thank you for watching, and now we will have the coupons and the final conclusion lesson. Hello everyone, welcome and congratulations on completing the Reactive Angular course. In this last lesson of the course, we're going to summarize some key lessons and takeaways. One of the most important lessons that we have learned throughout the course is that it's very simple to build our applications in reactive style if we keep them fully stateless or as much stateless as possible, meaning that we are going to store as little state as possible on our client, on our web browser, and we are going to fetch the data from the server whenever we need it in most cases. This allows us to build our application in a very simple way by adopting some of the stateless reactive design techniques that we have covered on the initial part of the course, and by designing our view layer where we split our components into top-level container components, also known as smart components, and more fine-grained presentational-only components. This approach of designing our applications to be mostly stateless while adding lightweight state management only where we need it works especially great for the case of enterprise applications. In the case of enterprise applications, the application server is running in a private network and is only accessible to a limited number of users. This means that there is a very strong, a very fast network connection between the user browser and the server, so bringing the data over the network from the server to the client multiple times during a browser session is really not that much of a problem for a fast private network, as it's usually the case in most companies. Also, the fact that the application is a private enterprise application means that it's only accessible to a limited number of users. That is typically well below a few thousand users. It could be a few hundreds of users or even less than that. So for this type of applications with limited traffic and a fast internet network, keeping the application mostly stateless tends to work very well in practice. Notice that this does not mean that the techniques that you have learned throughout the course are not applicable also to public internet applications. It just means that the techniques highlighted here of keeping the application mostly stateless while adding lightweight state management only when we need it works especially well for enterprise applications. One of the key ingredients for designing applications in reactive style is to design our service layer in order to have an observable-based API. This means that the methods that we call on our services don't return data directly. Instead, they are going to return observables that on their turn will emit the data. This means that our view layer is not going to be accessing directly the data of the application. Instead, the view layer is going to handle and configure observables that will then be plugged into the view using the Angular async pipe. So what is the big advantage of doing things this way? This means that our components don't need to manually subscribe to the data in order to feed it to the template. We can have only member variables that are observables that we then pass into the template using the Angular async pipe. The async pipe is going to take care automatically of the subscription to the observables for us, and it's also going to take care of the unsubscription from those same observables whenever the component gets destroyed. And this is done automatically without our intervention. This means that our components are going to look a little bit simpler, and this also means that there will be very little nested code in our components. This is because we are simply defining observables and passing them to the view, and we are not manually subscribing to those observables. If we had to manually subscribe to observables in our component, that would very quickly lead to situations where we have nested subscribe calls, which is a known RxJs anti-pattern. One of the main goals of RxJs, just like promises, is to allow us to tackle easily the asynchronous nature of JavaScript that tends to lead to callback hell, as we have shown earlier in the course. By defining our member variables as observables and by not having to subscribe to them manually in our component, this leads to very flat and easy to read code without the callback hell problem. As we have seen, not all Angular components are going to consume the observables returned by the service layer. That usually happens at the level of the top level component of a given route, also known as a smart component. This is the component that knows how to access the service layer, interact with it to fetch the correct data, and pass it to the template using the Angular async pipe. Now, the other type of components that we have in our application are going to be purely presentational components. These components take the input data via Angular inputs and usually don't interact a lot with the service layer, especially for fetching data. Regarding smart versus presentational components, a very important point. You should feel free to combine both techniques depending on the use case. And what I mean by that is you shouldn't build your components thinking that they always have to be purely presentational or purely smart components, otherwise they are automatically wrong and we need to refactor them. This is not a good approach. We should mix and match the different techniques in order to build the components that we need for a particular use case. For example, maybe what you need is a component that takes some inputs but also consumes some data from the service layer. This is a perfectly valid solution. Alternatively, you might have a leaf component in your application that is the end of your component tree that by some reason needs to access the service layer. This is also perfectly okay. You don't have to inject your services only at the level of the top level component of your route and then pass those injectables as inputs deep down your component tree just to avoid having to have a smart component as a leaf component in your component tree. There is no need for that. You can use the Angular dependency injection system in order to get access to any services that you need at any point of the Angular component tree. In this course, we also talked about component communication in a decoupled way. So sometimes we have two components that have a direct parent-child relationship, and in those cases, it's very simple to have the components interact via Angular component inputs and outputs, which are essentially events. Now, in many other cases, such as the loading indicator case or the messages panel case that we presented throughout the course, we have components that are at very different places of the Angular component tree, potentially in completely different branches or on the same component branch but separated by multiple levels. If we want two components in those situations to interact in a decoupled way, the best way to do that is via a shared service with an observable-based API. By using a shared service with an observable-based API, the components will not be directly aware of each other. Instead, the components are going to be aware only of the observable-based service. Any service in the Angular component tree that wants to broadcast a new value to the reminder of the Angular application simply has to call a publicly accessible method on the shared service. The shared service then exposes in its public API an observable. Any part of the application that wants to be notified of any changes on that observable, as usual, only has to subscribe to it. This means that we can have multiple different parts of our Angular application interact with each other in a completely decoupled way, not even being aware of each other's existence. They only know about the shared service and its public API observables. As we have seen throughout the course, it's not possible to keep our application completely stateless. There are situations where we do want to add some state management on the client side, for example, for handling the user authentication profile. This is a typical example that is going to exist in almost every application that you will ever build, where we want to load the user profile from the backend and we want to store it on the client side and keep it accessible in memory whenever we need it. We might need the user profile just about in any screen of our application in order to determine, for example, if the user is logged in or not, or if the user is an administrator or not. In those cases, we have shown how to build simple Angular services which are known as stores that internally use RxJs behavior subjects. The behavior subject has the very particular property of remembering the last value that was emitted. So if you subscribe late to it, after the last value has been emitted, you will still receive the last value. Another typical use case where we would want to do state management is for improving the user experience. So if you have in your application expensive network calls that force you to constantly show loading indicators to the user for extended periods of time, you might want to introduce some state management, either locally at the level of the component or even globally at the level of the whole application. As we have seen in the case of the master detail user interface pattern, sometimes doing state management does not mean using a shared observable-based service or even doing centralized state management. Sometimes the correct approach is to simply store the state locally at the level of the top-level component of a given route, typically a smart component. This has the advantage that when the component gets destroyed, the state will also get destroyed. One of the most important patterns that we have presented throughout this course was the single data observable pattern. With this pattern, we are going to provide to our template view only one data observable that we define in our component. This way, we only have to apply the async pipe once and not multiple times, nesting multiple ng container tags one inside each other, which is very ugly and difficult to maintain and reason about. This way, our observable data is going to be available anywhere on the template that we need it. At the very end of the course, we have seen how simple it is to take an application written in reactive style and incrementally convert it to on-push change detection if and when necessary. We can choose which components to convert to on-push, and this is very simple to implement because the whole application is built around consuming observables using the async pipe. The way that this works is that the Angular async pipe is directly integrated with on-push change detection. Whenever an observable emits a value that is getting consumed by the Angular async pipe, that component is going to get automatically marked as dirty and scheduled for re-rendering. And now, one final and very important note about everything that you have learned throughout the course. The simplified state management techniques that you have learned here, that are essentially behavior subject stores, will only work well if we are trying to keep our application as stateless as possible and we are only occasionally doing state management of certain parts of our application. If we don't try to keep the application as stateless as possible, and instead we try to scale these simplified lightweight techniques to do full-blown state management of the whole data of the application, these most likely will not scale well in complexity. If you want to do full-blown state management of all the data in your application and do as few HTTP or backend requests in general as possible, then in that case, I would recommend using a state management library such as, for example, NGRX. If, on the other hand, you are building a typical enterprise application that you want to keep as stateless as possible with only some occasional state management, then the techniques learned throughout the course for state management are ideal for you. And with this, we have reached the end of the course. I hope that you have enjoyed taking the Reactive Angular course. If you have any issues or questions, please let me know in the comment section below and I will get back to you. If you have any suggestions for future courses of the Angular University, I would like to hear from you as well. Again, thank you for watching and I will see you next time.